All right, so this is the Unit 3 review. And so we're going to talk really quickly. I'm going to try and go through chapters 5 through 7 and just do some sample questions and just talk about some of the important skills that we learned through chapters 5 through 7. So in chapter 5 was called Radical Expressions and Equations, and one of the things that we needed to know how to do was to express a term like this with a root sign that's called a radical as an entire radical. So this is a mixed radical right now, and this type is a entire radical. So again, this is a square root. So in order for the term outside of the square root to get into the square root club, it has to get squared. So you're going to write like this. It's going to be 2x is what was in there already. And then we can bring this grouping into or underneath the radical sign by squaring it. So this is going to be 3xy cubed all squared. Okay? And so when we do that, that will simplify to square root of, so we're going to have 2 times 3 squared, so that's 2 times 9, it's going to be 18. And we're going to have x squared here times x, so that's x cubed. And then we're going to have y. Now if you have a power raised to a power, you multiply, so it's going to be y to the 6, looks like. Okay? And that's the entire radical. Now, the trickier part, I think, would be a question like number 2, where we have to simplify a mixed radical, or into a mixed radical. So let's talk about this. And again, if we have the question, I'll just rewrite it here. 48 a cubed b squared c to the 5th. If we have something like this, what we're going to do is we're going to try and factor each part of this term into factors that are perfect squares. So you don't have to show this step when you do this on your test or whatever. But the largest perfect square that will go into 48 is going to be what? 16 times 3. So I'm going to split 48 up into 16 times 3. Does that sound okay? And then a cubed is actually a squared times a. So a squared is a factor of a cubed. That's a perfect square. Times b squared times c to the 4 times c. That's what c5 can be factored into. So from here, I'm going to take all my perfect squares that I've identified here, and I'm going to simplify by removing them from the radical sign. So the 16 comes out of the square root club as a 4. A squared comes out of the square root club as an a. B squared comes out of the square root club as a b. C to the 4 comes out of the square root club as a c squared. Now what am I left with inside? I still have to write down the factors that I'm left with. So that's 3 times a times c. So 3ac. Okay? Any questions about that, or you guys good with that? And let me know if there's anything that you're having problems with or you think I'm doing wrong. Okay? Or if I missed something. So let's take a look at number 4 just quickly. Again, I'm going to skip through this. So just, if we have to simplify expressions, you can add or subtract like terms. And those like terms have to have the same index of the radical. So again, the index is the number that would be in the notch of the root sign here. So there's nothing there, so that's a squared. This one here, see, that's a cubed. And again, that's pretty small for you guys at the back, sorry. But they have to have the same index and the exact same terms underneath the radical sign. So these are common, they're like terms. So I can simply go 4 plus 5 is 9 root 2a's. So that's my solution there. And again, restrictions on the variable, we know that we cannot have a negative underneath the root sign. So a must be greater than or equal to 0. Because if a was negative, that would make this whole thing underneath the radical sign negative, and that's a problem. So a would have to be positive here. Now this one here, we might want to do some simplification for b. So for 4b, I'll do 4b over here. And again, I'll just rewrite it. That's 10 root 20x squared minus 3x root 45. So I should simplify these to see if I can add or subtract them if they are like terms. So I'm going to take, out of here, I'm going to take a 4x squared. So a 4 is a factor of 20, and x squared is obviously a factor of x squared. So that's going to be 2x. I'm going to be left with a root 5 underneath there, okay? I didn't show that step, but do you guys see that? 4 times 5 times x squared. The 4 comes out as a 2. The x squared comes out as an x. The 45, let's see, any perfect squares that are, 9. 9 times 5, right? 45 is 9 times 5. So 9 can come out of the square root club as a 3. So 3 times 3, which is 9, x root 5. So the 9 comes out as a 3 times 3x is 9x. All right, so now I see that I do have common terms, and I can, actually, I got to simplify this. So this is 20x root 5 minus 9x root 5. I can simplify this now to 11x root 5, looks like. 11x root 5. And, of course, x here, because it's underneath the radical sign. This is squared. Okay. If x was negative, it would still be squared, so I think we're actually okay for restrictions. I have in my notes x greater than 0, but it's an x squared. X can be anything. It won't make that negative, will it? I don't think there are any restrictions. I agree with the textbook here. Anyways, disagree. So 11x, I don't think there's any restrictions on x, because if x was negative, because it's squared, it's still going to be a positive underneath the root sign. All right? Okay, rationalizing denominator. Let's skip down here. Let's do b. Let's do b. So if I want to rationalize this denominator, of course the denominator is the bottom part of the fraction, and in a, I could just multiply top and bottom by root 4. That would rationalize the denominator. That would be root 48 over 4. Square root of 4 times square root of 4 is 4. And I could simplify root 48 and I'd have my answer. For b, we've got two terms. So this is where you have to multiply by the conjugate. Okay? So I multiply by 2 minus root 3, top and bottom. And we do that because we're going to get a difference of squares on the bottom, which is great because I want to square a square root. And that will eliminate the square root. So I'm not actually changing the fraction by multiplying by something over itself. That's just multiplying by 1. So I'm going to have 2 times 2 minus root 3. I'll leave that as factors up top. And on the bottom, if I do a FOIL method here, I'm going to get 4 minus 2 root 3 plus 2 root 3. Those are canceled out. Minus root 3 squared, which is just minus 3. So I'm going to have 2 times 2 minus root 3 all over 1. Or here's my answer. Okay, so the denominator is now rational. It's rationalized. That's perfect. 6a. All right, so let's move to 7, number 7 here, because solving a radical equation is super important, right? Super important. So if I have root x plus 6 equals x, what I want to do here is I want to isolate the radical on one side. So this is isolated already. This radical is the only thing on this left side. So now I'm going to square both sides. And you can simply square both sides as a legitimate operation. And so if we square a square root, we just get what's left underneath there all by itself, x squared. And now I'm going to solve this quadratic. And this quadratic, it looks like it's pretty easy to solve. I'm going to do that just by intuition here. I'm going to go x is the first term here. And I'm going to go minus 3 plus 2. So x equals positive 3 and negative 2. Let's verify. Right? Let's verify that. So what I mean by that is let's check to make sure, because I don't want to be taking the square root of a negative number, which would be a problem. So 3 plus 6 is positive 9. Square root of 9 is the same as 3. Awesome. Negative 2 plus 6 is positive 4. The square root of 4 is positive 2. Oops. Positive 2 is not the same as negative 2 over here. See that? So when we square things, we're sort of treating positives and negatives the same. They end up to be the same, so we have a bit of a problem sometimes. So you're going to want to reject negative 2, it appears, for number 7. So x equals 3 is your only legitimate answer for number 7. Any questions there? Always check, right? Always check. Always check. Okay. Chapter 6 now. Okay, chapter 6, simplify expressions. And again, I'm going to do one of these expressions with a division. That kind of encompasses a lot of things. So I'm gonna do some. Let's do E. Let's do E instead. So I've got. I'm gonna do some simplification. I'm not gonna rewrite the question. So what I want to see. I see this division here. I'm gonna change that to a multiplication, but I'm also going to factor anything that I can factor on the top or bottom. So it's gonna look like this: x plus 2 over x minus 3. This is going to be x plus 3 times x minus 3. And on the bottom, it's going to be x plus 2 times x minus 2. And then this is going to be multiplied by, and I got to flip when I multiply. When I divide by a fraction, I flip and multiply. So this is actually going to be x minus 2 up top and x plus 3 on the bottom. Might be a good idea to note restrictions at this point. And again, I need to note restrictions from this factor, from these ones because they're in the denominator, but also from both of these because I'm dividing by this whole term. So x cannot equal 3, all right, plus or minus 2, see, right here, plus or minus 2. I've got the plus 2 there, and negative 3. So plus or minus 3 and plus or minus 2. That you're going to want to note about this time so you don't forget. All right, so now that I've got it expressed as multiplication only, I can take a look and see if I have any common factors on the top and bottom because all this is multiplied. Everything is multiplied together. So these x plus 2s are going to go. These x minus 3s are going to go. Those x plus 3s are going to go. And look at that. Wow. Everything's gone. So is the answer 1 or 0? Yeah, 1. Remember, we're dividing. We're not subtracting. We're dividing. So the answer is 1, looks like. Let's see. 9E. Yep, the answer is 1. With these restrictions, that's your answer. Questions? So number 10 here from your unit review says this. This is an addition subtraction question. So I tell you what, why don't we, well, let's just do 10A, I guess. Just pick any one. But just for sample's sake, remember we have to have a common denominator when we add or subtract any kind of rational. So over here, this is 10 over a plus 2. And this right now is plus a minus 1 over a minus 7. So what I need to do is I need to get a common denominator. So I have to multiply top and bottom here by a minus 7. Because the other term has an a minus 7, this one doesn't. And over here I need to multiply top and bottom by a plus 2. And you're only concerned with the denominators, not the numerators. Okay. All right, so what do I have up top? I have 10a minus 70 when I multiply this in. And I also have, this one is a squared. I'm going to multiply these binomials. Minus 2a, or sorry, plus 2a minus 1a is plus 1a. And then minus 2. And on the bottom, I have these factors here. I'm going to keep these as factors on the bottom because remember, we might be able to factor something out and simplify at the end. So leave the denominator as factors. The top you're going to have to multiply because there might be common terms. You can combine those together and then factor and go there. So you do have to multiply, get rid of the brackets up top and gather any like terms. For example, 10a and a. We didn't see that before, but we have to get those together. And 70 and negative 2, of course. So this next step is going to look like what? It's going to look like an a squared up here. We're going to have plus 11a here. And then negative 70 minus 2 is minus 72 over a plus 2 times a minus 7. Okay, you with me there so far? Now, if we can factor this top one, we probably should, but I'm having a tough time thinking of numbers that multiply to 72 and add up to 11. I'm thinking 9 times 8. That doesn't give me 11. 36 times 2. That doesn't give me 11. So I think we're stuck here. The only other thing we have to do is make sure, and I didn't do this earlier, but we'll have to take a look at what a cannot equal, and a cannot equal negative 2 and positive 7. So there's your simplified answer. Okay. You guys holding out all right? We'll keep going here. I won't do number 12, I don't think, but a couple things from number 12. When you have similar triangles, the proportions of corresponding sides are equal. So, for example, these two triangles, the big triangle here and the little triangle here, those would be similar triangles. All right? And so this side of 4 would correspond to this long side of x plus 4. And so you see the x plus 4 and the 4 are in a ratio together. Similarly, the long side of x is proportional to this side of the 3. So it equals x over 3. So we've got x plus 4 over 4 equals x over 3. And you can set up a proportion like that and simply cross multiply, divide, gather like terms, solve for x. So just know that you may have to do that on the test. Okay? Chapter 7, finally, this is our last chapter. What I want you to really notice here, for sure, you guys have to know how to interpret and graph absolute value functions. So remember, if you have an equation where you have absolute value signs and it encompasses the entire equation, then that means that the graph cannot be anywhere below the x-axis, okay? It cannot be over here anywhere because it's absolute value. Only positive values are allowed. And this 3x minus 6, this is the 3x minus 6 line, and of course absolute value means positive values are okay, but the negative values get flipped, right? The negative values get flipped up. And similarly here, this is what an absolute value of a parabola looks like. And if this parabola kind of looks like this normally, well, then the absolute value, the positive values are okay, but the negative values are not okay. They have to become positive and flip. And then again, positive values are okay. So that's where you get this graph from. To sketch these graphs, again, I would suggest start with the regular old function without the absolute value and sketch that. This is easy. Y equals -7. That's a point right here, the y-intercept. Go up 3, 1, 2, 3 over 1, 1, 2, 3 over 1, so on. Draw your line. Then go along and find out where this x-intercept is. Retrace the positive part, retrace that positive part, and then all of these points, flip them up. All right? And then connect the points, and there you go. You've got your absolute value. And same thing with this. Sketch this graph first, and then go ahead and flip it up. Okay? You can find x-intercepts, y-intercepts, all that good stuff. Sketch, and then make sure that all the negative values are flipped up. Solving algebraically, okay, this is another important part. I'm not sure what else we're going to go over. I guess a couple more graphs, so we're almost done. We're in good time here. But solve algebraically, so for A, 17a, right, this absolute value 2x minus 1, it means that the positive version of 2x minus 1 is a consideration, but also the negative version of 2x minus 1 is a consideration for this equation. So the positive, that's easy. 2x, we'll add 1 to both sides, is 10. X equals 5, all right? Over here, you could distribute this negative, or guess what? You could make this 9 negative. That maybe is a little bit easier, right? You could do that as well, because if you divide by -1, this is what you get. So however you like to do that. Now I solve for x, and x equals -4 when I add 1 to both sides and so on. So 2 possible values. I do want to check those, mind you. Always check if you can. So 2 times 5 minus 1 is absolute value of +9. Does that equal 9? Yes. What about -4? 2 times -4 is -8. -8 minus 1 is -9. What's the absolute value of -9? Well, it is a regular old +9, so that works as well. Both of these are solutions. With me? I know it's easy when I do it. Make sure it's easy when you do it as well, okay? So make sure you're doing this stuff tonight. Give yourself a chance. Okay, sketch the graph of f of x given the graph of the reciprocal. So remember, 1 over f of x is the reciprocal. And actually, I noticed on your last test, a lot of you did this incorrectly. So listen up. If I give you a reciprocal function, graph the original function. The invariant points are where y equals plus or minus -1. Remember that? On the reciprocal graph, the asymptote is where the original graph was 0. Boom. You have 3 points right there. All you do is connect them. And this graph is a line. The original f of x is a line when you have something like that. Okay? And a surprising number of you did not get this in the last exam. I had some of you do this. Some of you did this. Okay, there we go. It's right in between. I'll just fit that right. Nope. Nope. Did some of you do kind of like this? Oh yeah, it's right in here. Nope. Not there. And what was the other big one? I don't know. Those were the big ones. Okay. So copy the graph of f of x and sketch the reciprocal. Okay, so now we need to find the reciprocal. Okay, this is not absolute value. Please, please be careful, because some of you on the test, on the quiz or whatever, some of you did. Some of you did this. You sketched this graph, which is the absolute value of f of x. Okay, that's absolute value. We don't want absolute value. We want reciprocal. Okay. So wherever you see a 0, okay, wherever you see a 0, there and there, guess what? That's an asymptote, because 1 over 0 is bad. Very, very bad. That's an asymptote. 1 over 1 is 1. 1 over -1 is 1. 1 over -1 is 1. 1 over 1 is 1. You get the pattern there? Now, this is going to be tricky. Got to zoom in here. How do we get this right? Oops. Well, notice that. Okay, I'm going to actually erase this part here. Notice that from this invariant point, we go, if the graph is going to 0, the reciprocal is going to infinity. 1 over a very small number is a very large number. As the graph goes to infinity, the reciprocal goes to 0. Remember this? Same thing over here. Graph goes to 0, reciprocal goes to infinity. Graph goes to infinity, reciprocal goes to 0. Now, down here, from the invariant points, okay, this is easy, going to 0 to infinity, okay, 0 to infinity, okay. What about here? Oh, this value is just over -2, so let's say that's like 2.2. So guess what? What's 1 over 2.2? Wow, you don't know that offhand? Totally fine. Let's get out the calculator. 1 divided by 2.2. Why do I care? Because that's the reciprocal. I'm not going to 0. I'm not going to infinity. I'm going to this number. So -0.45. So guess what? Right about there. So this is what the graph looks like here. Follow that through. Connect that through. Nice smooth curve. There you go. There you go. Does that make sense? Any questions on that? Whoa, wrong way. All right. Okay, our time is drawing near, and that's kind of all I wanted to show you. There are other questions. If you have other questions, you can certainly ask, but that's just a general overview of all the important things you're going to need to do for this unit test coming up, and that's chapter 5 to 7 review. Okay, any final last-minute questions here? All right.